Welcome to the Irene W. Pennington Planetarium. Before beginning our feature presentation, let us introduce you to the constellations, planets, and other celestial objects visible at this time of year on any clear night here in southern Louisiana. What better place to learn about the stars and planets and how to locate objects in the sky than in a planetarium? To get our directions here in the theater, south is in front of you, north is behind you, east is to the left, and west is to your right. With this in mind, let's begin our journey through the daytime and evening summer skies. These long summer days will eventually lead to warm summer nights. After a summer sunset, what are we left with? A vast, starry veil. And with a trained eye and a little bit of knowledge, we can begin to distinguish the planets from the stars, the hazy band of our Milky Way galaxy, and even a few deep sky objects. When you look up into the sky tonight, you may be able to form your own starry connect-the-dot picture patterns. Well, this is what the ancient people did back in their time, resulting in the 88 officially recognized constellations we know today. A constellation is formally defined as a region of the celestial sphere with boundaries laid down by the International Astronomical Union. Constellations are usually based on asterisms, which are chance groupings of stars in the sky that resemble familiar patterns. Some constellations contain asterisms within them. For example, the Big Dipper is an asterism located within the constellation Ursa Major. Well, the asterisms that make up the constellations were seen by ancient people as patterns in the stars. Their origins date back hundreds or even thousands of years. Ancient cultures in different parts of the world have assigned different patterns to these star groupings. There are 50 constellations that date back to ancient Greece, Rome, and the Middle East. Many of these ancient constellations are associated with the rich mythology of the time. The other 38 are much more recent. It's important to note that the patterns the ancient people saw in the stars had a great deal to do with the particular beliefs, myths, and ideas shared by the people viewing the sky in a particular region at a particular time. What the Chinese saw in the sky was different than what the Greeks saw, and in turn, the Greeks saw something differently than what the Egyptians saw. For example, 3 of the officially recognized constellations are part of an asterism commonly known as the Summer Triangle, and it is composed of the stars Vega, Altair, and Deneb. The star at the bottom of the triangle is called Altair, and it is the brightest star in the constellation Aquila the Eagle. The star at the top of the triangle is Vega, the brightest star within the parallelogram pattern known as Lyra the Harp. And finally, the third star in the triangle is Deneb, representing the tail of Cygnus the swan. The ancient Greeks may have seen a swan representing Cygnus, but the Egyptians saw the hen in flight. According to the Egyptians, meat was a luxury and eaten only at special occasions. So the hen in flight is meant to represent a time for festival feasts. Furthermore, instead of seeing a harp representing Lyra, the Egyptians saw a vulture. This vulture represented Nekhebit, a goddess of the south. Its outstretched wings offered protection to the king. It was often seen in funeral art and in the crowns of pharaohs. The Summer Triangle and its 3 stars within their own constellations are just a few of the things you can find in your sky this season. Take a moment to look around. Of course, stars and constellations aren't the only things we can find in our night sky. This season, we can find a number of planets if we know where to look. An hour after sunset, you can find Saturn and Jupiter on the southeastern horizon. They'll appear as faint points of light, but visible with the naked eye. Then, as midnight approaches, you'll be able to see the red planet Mars coming over the horizon in the east. Let's venture out to Jupiter. Recently, the Juno spacecraft has been sending back mind-blowing, detailed images of Jupiter like we've never seen before. NASA's Jupiter mission has also provided its first results on the amount of water in Jupiter's atmosphere. The results estimate that at the equator, water makes up about 0.25% of the molecules in Jupiter's atmosphere. This may be more than what scientists expected, but it pales in comparison to what may lie beneath the frozen surface of Enceladus, one of the frozen moons of Saturn. This little moon may only be 310 miles across, but its remarkably smooth, icy surface may hide a gigantic ocean underneath. If scientists are correct, this ocean could be up to 6 miles deep in some areas underneath a layer of ice that is 20 to 25 miles thick. Speaking of water, what about that other planet we can find in our summer sky, Mars? Well, it is believed that most of the remaining water on Mars is frozen in the ice caps or trapped beneath soil. But a small amount of muddy, brackish water can be seen moving down the side of Martian hills in the local summer. Also, it is believed that billions of years ago, Mars had an abundance of water. However, since Mars has a small core, weaker gravity, and a thinner atmosphere, it was unable to hold on to its water. Over time, the water on Mars evaporated out into space. Yes, at one point, Mars had rivers that flowed intermittently but intensely, at some point early in its 4.5 billion years of history. This summer, you can find Jupiter in the constellation Sagittarius. Then, a little further to the east, you'll find Saturn, in between Sagittarius and Capricornus. Finally, you'll find the red planet Mars, a tad below Pisces. But you may be asking yourself, why do we still use constellations? Well, let's take the constellations making up the Summer Triangle. They're just 3 of the official 88 constellations that divide the sky into sections or regions. And these regions have boundaries. Think of it as real estate, or a map, helping us find our way across the sky and far beyond. For example, if we look over to the constellation Virgo, we can find a supergiant elliptical galaxy known as M87. You may have heard of this deep sky object. It's one of the most massive galaxies in the observable universe with a supermassive black hole at its core. And it's this black hole that was imaged using data collected from the Event Horizon Telescope. This black hole is the first and, to date, the only to be imaged. It sits some 53 million light years from Earth, surrounded by trillions of stars. It's hard to comprehend just how enormous M87 really is from this perspective in space. The image of M87's powerful jet stream may look ordinary and unspectacular, but really this entire jet stream extends out across 5,000 light years. In fact, as we look at it from our vantage point here in space, we can see that the innermost edge of the black hole's accretion disk spans the width of 5 solar systems with a mass 7 billion times greater than the Sun. From here, we can see the shadow of the black hole silhouetted against the smoldering material spinning around it. The black hole absorbs the light from behind it, and anything, be it matter or light, that falls past this spinning disk or the event horizon is gone forever. So we can't actually see the black hole itself, only the shadow of it as it is set against the bright, heated material circling it. M87 can be found in Virgo, along with many other galaxies and deep sky objects. This zodiac constellation is an ideal place to point your telescope on a dark night and is considered a galaxy hunter's paradise. Speaking of the zodiac constellations, Sagittarius and Scorpius appear to be engaged in some sort of battle. The ancients may have not had much of a problem resolving the stars of Sagittarius as an archer, but today most of us see and call it by the less formal name, the teapot. In fact, under a dark sky you can even find a cloud of steam rising from the teapot's spout. This steam is, of course, the hazy light of the Milky Way Band. When we look at the band of the Milky Way, we're actually looking directly into the disk edge on. The stars nearest to us and furthest away pile up over and across thousands of light years. This creates the impression of a thick band of light. In fact, this is why it's so difficult for scientists and astronomers to image the black hole known as Sagittarius A, nestled in the center of our own galaxy. It's like trying to see the center of a huge forest when you're standing on the fringe. In order to see Sagittarius A, we would have to see through a vast distance loaded with stars, dust, planets, and gas. That being said, if we were able to look at our galaxy from up above, we would see that it looks like a gigantic flattened pinwheel. However, this pinwheel would stretch out 100,000 light years from edge to edge, with a thickness of about 1,000 light years. The Sun, our Earth, and the rest of the planets in the solar system reside some 26,000 light years from the galactic center along a spiral arm called the Orion Spur. Our star is just one of up to 400 billion stars. As far as we know, the stars outnumber us by leaps and bounds since there are only 7.3 billion human beings in the galaxy. With that in mind, we encourage you to venture out into the night to gaze up at the stars with renewed interest and enthusiasm, and contemplate our unique place within the universe.